Okay, this is objective 9 for unit 2. It's the last objective. We are dealing with absolute value. Now, we've been dealing with absolute value already for a little while. We are simplifying things that are in an absolute value, and as we simplify, we need to be able to simplify it and get rid of the absolute value signs and then simplify it as much as we can. So let me remind you of the definition of absolute value. So the absolute value of A is equal to A. You just drop the absolute value signs if the inside is non-negative. So if the inside is greater than or equal to 0. On the other hand, if the inside is negative, then you drop the absolute value signs and multiply by -1. Okay, that's the definition. So simplify completely. So the final answer, no absolute value in the final answer. Pi minus 5. Now, we know that pi is approximately 3.14. So pi minus 5, wouldn't this be a negative value on the inside of the absolute value? And so if the inside is negative, then the rule says we multiply by -1, and we get 5 minus pi. Okay, that's all we want. That's the final answer. Now, negative pi plus 5 is the same thing. Let's try another one, though. So, number 2, we've got absolute value of root 15 minus 4. Okay, now what about root 15? Well, root 15, what's root 16? Root 16 is 4, so root 15 is a little bit less than 4. So a little bit less than 4 minus 4, the inside is negative. Since the inside is negative, we have to follow the rule for the inside being negative. And we're going to do -1 times root 15 minus 4, which is 4 minus root 15. Okay, moving on. Number 3, absolute of root 17 minus 4. Okay, well, root 16 is 4, and root 17 is a little bit more than 4. So a little bit more than 4 minus 4, that means the inside here is positive. And if we follow the positive rule, you just drop the absolute value bars, and we have root 17 minus 4. Number 4, the absolute value of 9 minus x squared. Now, if we have an unknown in there, we have to know something about the unknown. And so notice I already have a comma ready to go here. There has to be some extra information that we're being given because we don't have enough information at the moment. So let's say we're given information if x is less than -3. Well, what kind of values are less than -3? You know, like -4, -5, -6, so on. What if x was -4? Well, what's -4 if you square it? -4 if you square it is 16, and 9 minus 16 is negative. We would have to follow the negative rule. Now, it might be that, I mean, realize -4, I mean, that's, what if it was like -3.1? Well, -3.1, if you square it, is a little bit more than 9. 9 minus a little bit more than 9 is still negative. So we are following the negative rule, and so that tells me that the absolute value of 9 minus x squared is x squared minus 9 if x is less than -3. Okay. Number 5, which, by the way, is really problem number 18 from your worksheet. So absolute value of 3x plus 1 minus the absolute value of 2x minus 7 if x is greater than 0 but less than 3. Okay, so yes, it's possible to have more than one absolute value bar and then operations in between. So deal with each one separately. Okay, so if x is between 0 and 3, not equal to 0, not equal to 3, but between 0 and 3. So, well, if x is 1, the inside's positive here. If it's 2, the inside's positive. In fact, for any of these values, the inside here is positive, which means we get to just drop the absolute value bars. Now, we are doing a further operation, so I'm going to go ahead and do parentheses. So 3x plus 1. And then here's a minus. Now let's see what's going on with the 2x minus 7. Well, if x is 1, that would be negative. If x is 2, this would be negative. In fact, even if x was 3, now it says all the way to the 3, but not including 3. But even if it was 3, it'd still be negative. So the inside here is negative. And the negative rule says we're supposed to multiply the inside by -1. Now ignore all the other stuff outside of the absolute value. We have to multiply that by -1. So that would become positive 7 minus 2x. And I've gotten rid of the absolute value there, parentheses. Now we have to continue until we've simplified completely, which means performing the operation, combining like terms and everything. So this would be 3x plus 1 minus 7 plus 2x, which is obviously 5x minus 6. Okay. Problem number 6. Okay, problem number 6 is the square root of 4x squared minus 20x plus 25 if x is greater than or equal to 5/2. Now, at the moment, you might be looking at this and you might be saying, well, there's not even any square root, or I mean, there's not even any absolute value there. But let's see what we can do to simplify it. If we have even roots, we look for pairs of things, and for example, the inside, it looks like the inside can be factored. GCF is 1. It is trinomial. Looks like 2x, 5, and 5, and both negative, which means that this is actually 2x minus 5 quantity squared. And the square root of 2x minus 5 quantity squared is absolute value of 2x minus 5. There is the absolute value. You were maybe worried that there was no absolute value. Here's the absolute value. Now, if x is greater than or equal to 5/2, well, if x is greater than or equal to 5/2, well, if it's 5/2, that would be 0. Absolute value of 0 is obviously 0. If it's greater than 5/2, so let's say it's 3 minus, that's the inside positive. We know that the inside is positive, or at worst 0, and 0 goes with the positive rule, so we get to just drop the absolute value bars. So 2x minus 5 if x is greater than or equal to 5/2. Now, I've got a question for you, though. What if the exact same problem, but instead of if x is greater than or equal to 5/2, what if it had said if x is less than 5/2? So same original problem except for the if. So what if it was if x is less than 5/2? Well, we're dealing with absolute value of 2x minus 5 And if x is less than 5 halves, then the inside is actually negative now. And we follow the negative rule, and we multiply the inside by -1, which is 5 minus 2x, if x is less than 5 halves. Okay, and so we have some problems that are just like that. That's not the entire worksheet. We have some other problems, and so let me get to that type of thing. And so problem number 7 here, we are going to rewrite as a piecewise function. And the original problem here is y equals 2 absolute value x plus 3 plus 1. Okay, so we want to get rid of the absolute value. We're going to write it as a piecewise function. So really this is equal to, and we first we need to figure out where the dividing line is. Well, the dividing line is whatever makes it 0 inside the absolute value. So what value of x will make it 0 inside the absolute value? So inside the absolute value, when x equals -3, that's the dividing line. So that makes it 0 on the inside. So we would have the left of it, x less than -3, and we also have the right of it, x greater than -3. Okay, now we want to figure out which one's which ones gives us positive values on the inside of the absolute value, and which one gives us negatives on the inside of the absolute value. Well, if you think about it, if x is less than -3, like -4, -5, isn't the inside negative? Yes. So the inside is going to be negative for x less than -3, and greater than -3, so like -2, -1, 0, etc. There's more than that, but that would be, the inside would be positive. Okay, so we put the equal sign. The equal sign goes, the equals -3 is going to go with the positive rule, because that's what the definition of absolute value does, where the inside is equal to 0. The 0 goes with the positive rule. Okay, so writing the piecewise function now here. We need the domain restrictions, obviously. And we typically put the one on the top is typically the one that's furthest to the left. So x less than -3 is the one that we'll put on top, x less than -3. And x greater than or equal to -3, then we'll put on the bottom. Okay, and remember that the negative rule, the way we drop the absolute value with the negative rule, we have to multiply by -1. So if we multiply the inside by -1 and drop the absolute value bar, so we would have 2 times -1 times x plus 3. So I'm multiplying the inside by -1 plus 1. So I've dropped the absolute value bar. I'm multiplying the inside by -1. So really, it's -2 times x plus 3 plus 1. Okay, now that's linear, and that's one way we could write it. Or we could distribute -2 and get -2x minus 6 plus 1, which obviously simplifies to -2x minus 5. Now, when you're checking answers, it's probably going to be in the y equals mx plus b form. But this is another possibility for how it could be right there. And that matches up to the x is less than -3. So I'm going to do the mx plus b form. So -2x minus 5 goes with the x is less than -3. And so now the positive rule, well, when the inside is positive, we just drop the absolute value bars. So we have 2 times the quantity, x plus 3 plus 1. That's a possible way. Sorry, the lights just went out. They'll come back on here in just a second. Okay, that's a possible way to write the equation of the line, or we can distribute 2 and get 2x plus 6 plus 1, which is obviously 2x plus 7. So I'm going to put the mx plus b form in there. Okay, and so we have rewritten the function as a piecewise function without absolute value, and so y equals that piecewise function. Okay, last problem I'm going to do with you, problem number 8. We are going to sketch this graph, and it is y equals 5x plus 20 all over the absolute value of x plus 4. Okay, now, because there's absolute value in there and it's a fraction, I mean, we haven't even done anything quite like this. Perhaps Mrs. Lummis did something like this with you before she left, but no, we basically we want to write a piecewise function so that we can see what the equation is really looking like. Now I'm noticing that the top factors, and so the top has a GCF of 5 times x plus 4 over absolute value of x plus 4. Okay, now where is the dividing line if we're writing a piecewise function? Well, what makes it 0 in there? So x equals -4. Okay, so that's the dividing line. We've got to the left of -4, and we've got to the right of -4. Okay. Now, okay, well, let's figure out which one. Okay, so if we go to the left of -4, so the inside, the left of -4, so like -5, -6, and so on. The inside would be negative, and so we're following the negative rule if we're to the left of -4. If we go to the right of -4, then so like -3, -2, -1, so on, the inside is positive, and we follow the positive rule. Now, unlike the last one where we had to figure out where to put the equals, at -4 we get 0 in the denominator. Can we ever divide by 0? No. So x equals -4 is not actually in the domain of the function. The function is undefined there. So just those values. Okay, so piecewise function here. We've got x less than -4, and we've got x greater than -4. Now the less than -4 is negative rule, so I have 5 times x plus 4 over, and I would have -1 times x plus 4. But notice the x plus 4 is reduced, and we're left with -5. Y equals -5, horizontal line. For the x greater than -4, we follow the positive rule. So I have 5 over x plus 4 all over, and it comes out of the absolute value. So I've got over x plus 4, and that reduces to +5. So y equals +5. Another horizontal line. Now, here are the domain restrictions, so don't forget about the domain restrictions. So if we did a quick sketch here, negative 4, and I need a positive 5 and a negative 5. Okay, so if I'm to the left of negative 4, I've got y equals negative 5. So here's negative 4, and y equals negative 5 goes to the left. If I'm to the right of negative 4, I'm at positive 5. And there's our sketch of the graph. It's y equals negative 5. To the left of negative 4, it's y equals positive 5. To the right of negative 4, and the function is undefined at x equals negative 4. Okay, so if you don't already have the absolute value worksheet, we're going to pass that out to you right now, and you can go ahead and work on it. Now, notice that there are odd answers on the back, so you can check as you're going along, and that's an important thing to do.